All right, hello and welcome. Today we are diving into the evolution of a technology that is kind of quietly changing how AI sees the world. It's called Retrieval-Augmented Generation, or RAG for short. We're going to see how it went from a simple fix for a huge AI problem to a truly revolutionary way of building intelligent systems.
You know, this quote from Amit Sheth, it just nails it. It gets right to the heart of why RAG even exists in the first place. These large language models, LLMs, they're incredibly powerful, no doubt. But just like the quote says, they're inadequate all by themselves. They have this fundamental weakness that stops them from being truly reliable.
So what is this big inadequacy? Well, it's a massive blind spot. I want you to think of an LLM as this brilliant student who has memorized an entire library. But here's the catch. That library was sealed shut back in 2022. It can't look up real-time news, it can't access your company's private docs, or anything new that's happened in the world since its training data was frozen.
And this blind spot, it leads to some really serious problems. I mean, their knowledge is literally frozen in time, so you can get outdated information. They don't have deep expertise in specialized fields like medicine or law. And of course, the most famous problem, they hallucinate. They just confidently make stuff up. Now, the alternative, fine-tuning, is kind of like re-enrolling the model in school. It's incredibly expensive and takes a ton of time.
So, developers came up with this really elegant solution. Instead of trying to cram every piece of new information into the AI model's head, they asked, what if we could just give it a library card? What if it could just look things up on the fly, right when it needs it? And that simple idea right there is the foundation of Retrieval-Augmented Generation.
Think of it like this. A standard LLM is basically taking a closed book exam. It can only use what it's already memorized. RAG, on the other hand, gives that same LLM an open book exam. So before it answers your question, it gets to look up the latest, most relevant info from a specific knowledge base.
The very first version, which people now call vanilla RAG, works like a super simple assembly line. You ask a question, the system quickly finds a few relevant paragraphs from its knowledge base. Then it kind of staples those paragraphs to your original question and just hands the whole package over to the LLM to write a final, much more informed answer. It's simple for sure, but for a lot of basic questions, it's incredibly effective.
But you know, while vanilla RAG was a total game changer, its simplicity, well, that turned out to be its biggest weakness. As people started asking more and more complex questions, the cracks in this simple approach really started to show.
The biggest issue is what's known as the local window problem. So imagine you ask a question like, how did our company's marketing strategy in Europe affect our sales in Asia? Vanilla RAG might find a doc about the European strategy, and it might find another one about Asian sales, but it can't see the relationship between them. It just sees these isolated puzzle pieces, and it completely misses the bigger picture.
And this gets to the fundamental difference in approach. See, vanilla RAG is like reading random disconnected pages from a book. You get little snippets, but you completely miss the plot. The goal of these more advanced systems is to create a complete concept map of the entire book, to understand how every character, every place, and every event are all linked together. That's the power of a knowledge graph.
So this big limitation, it sparked a revolution. Researchers and engineers started developing these new, advanced RAG techniques, designed specifically to see that bigger picture. And the two most exciting frontiers right now are graphs and agents. So first up is graph RAG. Instead of just storing flat text, it builds a knowledge graph, which is basically a smart map of your data. Think of it like a social network for information. You have nodes, which are the concepts, and edges, which are the relationships connecting them. This lets the AI answer really complex multi-hop questions by jumping from one node to another. So it could answer something like, which colleagues of the project manager for Project X have experience with Python, by hopping from the project to the manager to their colleagues and then to their skills.
The real power of graph RAG comes from preserving both the tiny details and the big picture structure. And because it's following a clear path through the data, it can provide traceable citations, which drastically reduces hallucinations and lets it truly reason about how all the different pieces of the puzzle fit together.
Now, the other major leap forward is Agentic RAG. This is, well, it's like giving your data analyst an entire team of autonomous researchers. These AI agents don't just follow a script, no way. They can actually strategize. If a search of the internal database comes up empty, an agent might decide to use a tool, like a web search, or maybe query an external API for stock prices. And then it'll self-critique the results before it gives you a final validated answer.
So the shift here is profound.
We're moving away from that simple, fixed assembly line to a dynamic system that actually thinks. The AI is no longer just a passive retriever of information, it's an active researcher, one that's capable of strategizing and changing its approach based on how tough your question is.
But all this extra intelligence comes at a cost, and that cost is speed. As you can see here, while a basic naive RAG can answer in under 4 seconds, a really complex community graph RAG can take over 90 seconds to piece everything together. It's that fundamental trade-off, right? Do you need a fast, good enough answer, or are you willing to wait for a deeply reasoned, highly accurate one?
Okay, so that's all the theory, but what does this revolution actually look like in practice? Let's take a look at how advanced RAG is really being used today.
So why does any of this techie stuff matter to you? Well, the difference between a simple RAG and an advanced one is the difference between an AI that can fetch facts and an AI that can generate real insights.
I mean, the impact is already huge. In medicine, these systems can uncover hidden links between a drug and a side effect by connecting data across thousands of patient records. In business, it's powering enterprise search that can finally answer those complex questions by pulling info from documents, forums, and databases all at once. It's even letting non-technical users query a complex database just by asking a question in plain English. And here's the bonus. By making the AI smarter without constantly retraining it, it also makes AI more sustainable. You know, the entire evolution of RAG has really been about one thing: teaching AI not just to find information, but to connect it. And that leaves us with a pretty provocative final thought. AI is now incredibly good at finding the dots and connecting them. So is the next great frontier teaching it how to actually understand the picture that emerges? Thanks for tuning in.